This video is on binomial expansion. All right, so the first thing I want to show you, and you might want to copy this down on your paper, is Pascal's triangle. This will come in handy in today's lesson. If you're curious where these numbers come from, I want you to notice that on each side of the triangle, we have ones. So the easiest way to generate this yourself is to start with this little triangle right here of ones. And then as you add a 1 on each side, the next numbers down are just the sum of the two numbers above. So if I put all these arrows in, you'll see where these other numbers come from. So if I add those, or if I add those, you can see the patterns start to generate. All right, so again, make sure you have Pascal's triangle on your paper. All right, and then you'll notice, and again, this is just a tiny little snippet here, that here's a little piece of Pascal's triangle. And if you raise binomials, right, so x plus y in the parentheses here is considered to be a binomial. And if you raise it to powers, you'll start to see that the coefficients over here, right, are the same as you're seeing over here, right? Here's the ones, here's the 2, 1, 3, 3, 1, right? Same exact thing that you're seeing over here. Okay, so what we're going to be doing in this lesson is we're going to be taking binomials. Maybe it's x plus y, maybe it's x plus 2y, maybe it's x minus 5y. But we're going to be raising them to powers over here that are a lot larger than 3, right? Maybe 6, maybe 7, maybe 10. All right, and so the answer that you're going to get is going to be very, very lengthy, and you won't have to do it the long way. So like right now, if you were going to do this problem, you'd have to do x plus y times x plus y times x plus y, and it would take about half a page. You're going to be able to do this in a couple lines, 3 lines tops. All right, so probably the most important part here is these patterns. Okay, and again, I will let you pause the video if you need to. You can read them, you can write them down. I will sort of refer to them as I do some examples. Okay, so for this binomial expansion, the first thing that I want you to notice is that the exponent is a 6. Okay, what that means first is that there's going to be 7 terms. It's always one greater than that. Okay, so there's going to be 7 terms in this expansion. 1, 2, 3, 4, 5, 6, 7. Okay, now in each of those blanks, you have to have 3 things. You need to have a number that you're going to get from Pascal's triangle. Okay, so if you have it on your paper, like I said earlier in the video, if you have it all written out, you will see a line that has 7 numbers in it. So I'm going to fill those numbers in right now. There's a 1 and a 6 and a 15 and a 20 and a 15 and a 6 and a 1. Okay, so that's the first thing you want to do, is figure out how many terms is this going to have, and what is the number from Pascal's triangle that you're going to be putting in there. Okay, step 2, I'm going to switch colors here. Step 2, each of these lines needs to have something to do with the first letter or number or whatever you see inside the parentheses. There's going to be something dealing with x in each one of those blanks. Okay, so let me get rid of that. Here we go. So we're going to start on this first line. We're going to take that x and we're going to raise it to that power. And they are going to decrease all the way down. So this is going to be x to the 5th, and x to the 4th, and x to the 3rd, right? All the way down. Now this last one, I could write x to the 0 in there, but x to the 0 just equals 1, so I'm not even going to write it. Okay? And then the last thing that you're going to have in each of these blanks is something dealing with this positive y. Okay, and the reason I'm calling it positive y is because some of them are going to be negatives, and that is important. So for the y's, I'm going to start at this far right-hand side. Okay, and I'm going to start again with this exponent, and I'm going to decrease as I'm going towards the left. That's a 5. That looks horrible. Let me try that again. there we go, y to the fourth, y to the third, y to the second, y to the first. And again, in this last blank, or the first blank, I could put y to the 0, but that equals 1, and I'd have to simplify it anyway. So that's it. That's the entire expansion of x plus y to the 6th. Again, it has 3 things in every single blank, something dealing with Pascal's triangle, something dealing with x, something dealing with y. Sometimes you will have to simplify further than this, but for this first example, you are all done. Okay, so let me move this up and we'll try another example. Okay, so for this example, because this exponent is a 7, that means there's going to be 8 separate blanks that I need to fill in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'm going to start by putting in a particular number from Pascal's triangle. In fact, let me just put it like this, something from the triangle. All right, and you may have to expand it out a little further than you have it already, but the numbers that I'm looking at are 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so that's the first thing that's going to go in there. Okay, second, let me switch colors. I need something dealing with 2x. Okay, there's going to be a 2x in every single blank. The exponents start high, like this, 2x to the 7th on the left, and they decrease as we're going to the right, like that. All right, and then lastly, in every single one of those blanks, I need something that is dealing with this negative y, right? Every blank is going to have a negative y in it. I'm going to start over here on the far right with the highest exponent, negative y to the 7th, and then I'm going to decrease as I'm moving to the left, like that. Okay, now if you'll notice, this one, unlike the last one, right? The last one came out really nice and pretty and done in one line. This one, I need to go to each of these, every single one, all 8 of them, and simplify it. Okay, so for example, here, I may need a calculator if I don't know what 2 to the 7th is, right? Here, I'm going to have to do 2 to the 6th and multiply it by 7, right? So it may take a calculator. So I'm going to grab a calculator right now and write out the entire answer. And it should look like that. And again, you may have to play with your calculator, make sure that you get all those numbers correct. You can't turn it in this way, okay? You do have to actually simplify each line all the way out. Notice, and this is actually kind of cool, how the signs alternate, right? So it's positive, then negative, then positive, then negative, then positive, then negative. And that will happen every single time when you have a subtraction in the middle of your binomial, okay? Every time it's going to alternate signs. All right, so then let's do, I have one last example. All right, now to do example 3, notice it says find the third term, which means I don't necessarily have to expand it out all the way. So let me go back to example 2 and show you something that's kind of important, okay? What I want to show you on this example is that for any term, right, so let's just pick this one at random, this one right here. Notice that the exponents add up to be 7, okay? And that's true of any single term. Those add up to be 7, those add up to be 7, those add up to be 7, these add up to be 7 because there's a missing 1, okay? So when I try to do this example, okay, again, I'm not going to expand it all the way out, but there are supposed to be 6 terms. 1, 2, 3, 4, 5, 6. Now, it only wants the third one, right? This is the only answer that I'm actually looking for. So when I go to Pascal's triangle, and I know that I need to put in these numbers, a 1, a 5, a 10, I could fill in the rest, but why, right? I don't need the rest. I'm only trying to figure out this one spot. Okay, next, I know I need to have something dealing with x's. This one's going to be x to the 5th. That makes this one to the 4th. That makes this one x to the 3rd. All right, and then I also need a negative 3y in here And I know that it's going to have to be raised to the second power, because no matter which term I'm in, it has to add up to be 5. Okay, so now if I simplify this, let's see, I have 10 and negative 3 squared is 9, so I get 90 x to the third y squared.